this contains the most used of what are called the ISM bands. I'll talk about that in a second. Up from there, SHF, super high frequency, 3 to 30 gigahertz. Extra high frequency EHF, 30 to 300. 30 to 300 gigahertz. What's in here? There's more ISM. There are also satellites and large backhauls, backhaul point to point. If you've ever looked up a large radio tower and you see a big dish that's pointed in a certain direction, that's what I mean by backhaul point to point. It's usually used as a very, very high bandwidth link that just connects 2 points. So as you can see, as we go, starting here down, we can see the applications sort of become more and more and more recent. And that's because, as I mentioned, 20 or 30 years ago or 40 years ago or longer, when, let's say, AM radio and shortwave radio were in common use, they didn't really have the components and devices to do things in the gigahertz range. And furthermore, as new applications have arisen, we've had to see those applications have needed to find spectrum that was previously unused, and that's usually on the top end. So like I said, the only applications we have so far have gone up to about 100 gigahertz. We've still got about 200 gigahertz of room up here if we need it. But as you can see, we're starting to run out. So there may come a day when there's absolutely no more there's no more unlicensed spectrum left, and we'll have to make do with what we have. So a couple points about this. Firstly, each slice of spectrum is licensed for a specific purpose. And by law, cannot be used for anything else. So I say licensed. So a radio station does not own the spectrum. It licenses the spectrum from the federal government. So the federal government actually owns the spectrum. And when I give you these typical uses, that isn't just a suggestion or what it's used for in contemporary times. That is its legal defined purpose in law. So you can't, unless the law changes, you can't take FM radio spots and turn them into something else, for example. So for example, radio stations, the radio station is the licensee. They apply for a license. If they're granted the license, then they can use that block for radio. Radio stations are licensed by the government. And by law, can only use their spectrum, the licensed spectrum, for approved purposes. So for example, let's say a radio station can't go off, grab a license, start off with a radio station, but then decide, okay, that's not profitable, I'm actually just going to use this, I'm going to rent out this spectrum to wireless networking or something. They can't do that by law. That slice of spectrum can only be used for down. And that's why it's a big deal every time spectrum becomes available. So not so long ago, probably within the last few months, you may have heard of a spectrum auction. There's a band in around the 700 megahertz range that I can't remember what it used to be used for, but the government decided that was no longer needed, so this spectrum was auctioned off, and that spectrum, that available space, is sufficiently valuable. Oh, by the way, what they auctioned it off for were licenses for cell phones, so new cell phone space. Those spectrum licenses were sufficiently valuable that the auction got into the billions of dollars. Okay, one thing to point out here, ISM bands. These are important to us. The acronym is Industrial, Scientific, and Medical. But the acronym is obsolete. The important feature about these bands is that they are unlicensed and can be used for anything by anybody as long as power is low. Power is kept low. So in other words, you can't take the ISM band and plop down a transmitter and start a new radio station or something, because your power has to be kept quite low. So what's important about that is that anytime a new application for radio technology comes along, probably what they're going to do is they're going to stick it in the ISM band, because they don't need a license. So you don't need a license to manufacture equipment or to offer services to the public. And for that reason, new services such as Wi-Fi have gone here, as has Bluetooth. There's another protocol that's becoming interesting called Zigbee that also goes here. This is for low power devices that communicate at low rate. And if you've ever heard of a sensor network, they run on Zigbee. So there are actually a lot of ISM bands, but the most important one is around 2.4 to 2.5 gigahertz. And that's where one of the main Wi-Fi bands is located. That's where Bluetooth is located, and one of the Zigbee bands is located. Okay, so that's basically just background information. So the takeaway message here is that you can't just design a radio and throw it out in the world. You can't conceive of a radio application at an arbitrary frequency and start selling services to the public because things are licensed. You need a license to do that, unless you do it in the ISM band. So if you come up with a brilliant idea, probably what you're going to do is you're going to stick it in the ISM. Yes?
I was just wondering about licensing in the States versus Canada. So you said there was an auction, I think that was in the States, but how does it, just because we have such a giant shared border?
That's correct. Actually, it's backwards. So most of these licenses are governed by international agreement. So for instance, the ISM band, with some exceptions, are international. The spectrum auction that I just mentioned was actually in Canada, not the United States.
Oh, sorry.